Hello and welcome to Education at SSBJ online video tutorials. We shall take up a chapter number 14, Chemical Effects of Electric Current. Electric current, or we'll refer it as electricity. What is electricity? We have studied about electricity in class 7th as well as in a chapter named Natural Phenomena, and we know that electricity is flow of electric charges. Now wait a minute. You must be thinking, what are electric charges? Please recall the structure of atom. And what does atom contains? Atom contains mainly a nucleus, right? And what does this nucleus contains? Nucleus contains few more particles, main particles such as protons and neutrons. Now if I can show proton as P and neutron as N here, to be familiar with the structure of neutron, we can just represent this figure in this way, right? So here it is P stands for proton and N stands for neutron, right? And they are equal in number. If there are two protons, there will be two neutrons in most of the cases. If there are three protons, there will be three neutrons, and so on. Now let us talk about the properties of these protons and neutrons. The protons and neutrons have some properties. For example, neutrons are neutral in nature, whereas protons are positive in nature. What do we mean about this? What do you mean that the charge of proton is positive, and what does that charge mean? Charge is a kind of a force which is experienced by the proton. So neutron doesn't experience any force, so it is neutral, right? And a kind of force which is experienced by the proton is referred as positive. And that means this nucleus, in this particular example, nucleus contains three protons, which means three positive charges are there. And these neutrons, since they are neutral in the charge, the entire charge of the nucleus is 3 plus, we can say, right? So nucleus is positive. So remember, atom contains a nucleus which is always positive. Do we have only these particles in the atom? No. We have already studied there are few more particles, and those particles are around the nucleus. They are called electrons. So they are denoted here by the letter E, right? So these are electrons which we have studied. Look at this, electricity and electron, the word, how this must have come. Right? Now you can make out that there is some relation between electricity and electrons. Right? They start with the same spelling. Now where are these electrons? Electrons are revolving around the nucleus in their own path. Some electrons are closer to the nucleus, some electrons are far away from the nucleus. And they carry a charge which is negative in nature, right? So recall, protons are positively charged and electrons are negatively charged, and charge is nothing but a kind of force experienced by this. And we have studied that like charges. What do you mean by like charges? Like charges, for example, positive and positive, negative and negative. These like charges, they repel, right? They repel, they move away. Whereas unlike charges, positive and negative, they attract. And that is the reason this entire nucleus, which is positively charged, is attracting the electrons which is negatively charged. Since they are a bit away from the nucleus, they will be revolving around the nucleus. So in this case, some electrons are very close to the nucleus. They are attracted more than the electron which is far away. Just like the planet which is far away from the sun is attracted less by the sun. So this is the electron which can be made easily free. Free in the sense we can take this electron and use it for some other work, provided you give a kind of push to it. Right? And therefore these electrons are called free electrons. Right? And these free electrons are in metals, or more to say metal wires. And that is why metal wires are good conductors of electricity. So you know the reason why metals are good conductors of electricity, because they have more of free electrons. And you also know that what are free electrons, right? So we can show some of the free electrons right on the metal here. But unless they are pushed, you cannot make these electrons to move. And once you push them, and if the electrons move, that is what is called flow of electric charges. And that is what is called electric current. And how can we do that? So connect it to a source of electron again. And what is this source of electron? It's a cell or a battery. Right? And there are many electrons which are there already before because of the chemical reactions. Now, once you connect it, suppose this is a positively charged terminal and this is negative, right? The electrons will start moving from negative terminal and push all other electrons, and the movement of electrons starts all over the wire, and then we say that there is a current which is flowing into the wire, right? And you know that in metals electrons are free to move, therefore metals are good conductors of electricity. What about liquids? Are liquids conduct electricity? We can use a same arrangement to test whether liquids are good conductors of electricity or not. And how we can do that? Just open this circuit, right, and connect extra wire here. Put them into the beaker where you have already put few drops of lemon juice and mix it with water. So this is a lemon mixed water, right? And then you will find electrons flow, because lemon juice which is there in water will allow the electrons to flow inside the liquid. So lemon juice is good conductors of electricity. But how do you know that? Create a space here, cut this wire and connect an LED. I told a positive terminal of the circuit will be connected to the positive terminal of LED, and then negative terminal will go for the negative. In this connection, if you continue and put a switch somewhere here, the moment a switch is on, the LED will glow. And that proves that the lemon juice conducts electricity. What about onion juice? That also will conduct electricity. What about other vegetables? Take a tomato juice, and that also will conduct electricity. Take even the soap water. In place of this, you will have a LED on, which means that electricity is flown through the circuit, And therefore, vegetable juice, soap water, and even if you can take a salt water, put some salt into the water and then do the same experiment, you will find salt water also will conduct electricity. Right? What about tap water then? Tap water contains some salt. It's not a pure water. And if you take salt water, there also you will see that it allows the electricity to flow. And therefore, a salt water is also a good conductor of electricity. What about distilled water? And what do you mean by distillation? Distilled water is that water which is a pure water which doesn't contain any of the minerals inside. Right? It's pure H2O. And how is it obtained? You just convert it into vapor and then condense it into a water again. And that water if you take, then the LED will not glow. And therefore, pure water is not a conductor of electricity. Remember this. But rest of the solutions here such as salt, soap, onion juice, tomato, lemon and other vegetable juice, they provide an environment for the electrons to move. And that's why they allow electricity, whereas the pure water will not provide that same environment for the movement of electrons. With this information, let us start to know about meaning of chemical effect, because the name of the chapter and the topic which we are going to study is a chemical effect of electric current. And so far you know what is meant by electric current. Electric current is flow of charges, or more specifically we can say in metals it is flow of negative charges. Right? Now, chemical effect of electric current. What do you mean by chemical effect? The effect which brings chemical change. Right? So, any effect which brings a chemical change is a chemical effect. And what does chemical change mean? Now, what is the meaning of chemical change? And then how electric current causes chemical change, we shall study in the next video tutorial.